Now we will study the cumulative distribution function. Cumulative distribution function, we will explain the cumulative distribution function through this example. So now, the number of hours Nabila spends each day working in her garden is modeled by continuous random variable x with probability distribution function f of x defined by this one. So find the value of k, sketch the graph of f of x, find the probability that Nabila will work between 2 and 5 hours in her garden on a randomly selected day. So now, solution. The first part here in the solution is to find value of k. From last session, we learned that for this, we see here the function consists of 3 parts, 2 parts, and 1 is 0. This 0 may be ignored in this case. The process or the procedure to calculate the k, now we knew that f of x for probability distribution function must equal to 1. So, and I'll integrate from minus infinity to infinity. Actually, here I have only in this range and this range, we have value for the function. So the integration is, instead of being from minus infinity to infinity, it will be only in these two ranges. That means minus infinity to infinity, f of x, it will be composed of 2 parts. The first part is k of x dx, and I'll integrate from 0 to 3 and the plus this one, k 6 minus x dx, and it will be integrated from 3 to 6. If I integrate these two, the integration will, for the third one, it is ignored. Why? Because it is 0, so it does not have value. Okay, if I integrate this one, k is a constant, so this means over 2, and the integration is from 0 to 3. And then this one is 6, because this one I can write it k 6k minus kx. So if I integrate this one, it will be 6kx, because 6 constant, k constant, minus kx, it is k over 2 x squared, and the limit is from 3 to 6. Okay, if you evaluate this one, after mathematical manipulation, definitely you know how to do it, then this one can be 9k. You can show that this one, after manipulation, it is 9k. Okay, and then this 9k, which is this one, must equal to 1. Then k equal 1 over 9. So this one is the value of k as required in part I. Now, part 2.